Okay, so today's lesson should be relatively short because it's basically built upon what you have done yesterday to see if you know the identities, and then we're gonna jam in something that you learned previously to extend the application of these sum and differences identities. So cosine A plus B is cosine A cosine B minus sine A sine B. Okay, cosine A minus B would be very similar to the previous one, except that it is a plus instead of a minus. Sine A plus B is sine A cosine B, but the sign would be the same, right? And then you have cosine A sine B. Okay. The next one, it's very similar, except that you have a subtraction instead. Okay. All right. And then we have tangent A plus B. And tangent A plus B is tangent A plus tangent B, and 1 minus tangent A tangent B. And then for the tangent A minus B, it is tangent A minus tangent B, and then 1 plus tangent A tangent B. All right. Now, I would tell you that I did not really think of memorizing all these things. It's just that when you write so often, and somehow it just gets stuck in your mind. It's just like, Pythagorean theorem, a squared plus b squared equals to c squared. Now, if I ask you to erase that part of the erase Pythagorean theorem in your memory, then you're like, wait, hold on. Can't, because you have done it so many times already. So that's the same idea. The more you do it, the more you write it, the better you will become. All right, so make sure you know how to write all of them here. All right, now, so what's new? Okay, well, what's new here is this. Well, if you look at the expression right here, it's cosine u minus v. So if you're going to write it, you'd be like, oh, well, I know how to write it. It's cosine u cosine v plus sine u times sine v. So we're like, okay, we got that. Well, what are those values? Well, you have something given. We say, hey, guys, sine u, it's cosine u, it's 4/5. And sine v, it's negative 5/13. Now the question is, what about cosine v and sine u? Okay. So we say, well, they give you some good information, such as they tell you that, hey, look at this u thing right here, this angle u, it's in quadrant 1. And they give you cosine, they give you the ratio, it's 4/5. That means, hey, we have this little triangle right here. And this is 4, and this is 5. Well, guess what? It's the what the opposite side is. It's gotta be a 3. So if I need to get the sine u, it's gonna be 3/5. It's got to be 3/5. It's positive because it is in quadrant 1. Always be careful with the quadrant. And if you say, well, I'm not too sure about quadrants, then I'll suggest you to write something like this, ASTC, just to remind yourself. Okay, telling you which quadrant it's positive for which function. All right, and then for the little angle V is in quadrant. That will be in quadrant 3. And it tells you that the opposite over hypotenuse, it's 5/13. So cosine of an angle that's in quadrant 3, it's going to be negative. And if you have the opposite and hypotenuse as 5 and 13, the adjacent side must be 12. So one of those Pythagorean triplets. Okay, so that means you can tell cosine of V is, again, quadrant 3 of cosine is negative. So negative 12/13. So that's really the only new thing that we are extending today. We're saying that hey, we have a little triangle right here. So we would like to extend. We would like to add them all together. I mean, we would like to have a triangle and get the other missing ratios.
Can you explain how to find the answer by drawing a triangle? I kind of got lost.
Well, maybe I should also label that these are the angles. So if they tell you cosine U, it's 4/5. That means adjacent over hypotenuse is 4 over adjacent is 4, hypotenuse 5. Then it's a 3, 4, 5 triangle. Okay, so if they tell you that sine D is 5/13, so opposite over hypotenuse is well, opposite is 5, hypotenuse 13, and that means the adjacent must be 12. Okay. Now, if you don't know the Pythagorean triplets, you can use Pythagorean theorem to find out. So now that you have all the values, so just like what I taught you yesterday, go ahead, use parentheses, and just go ahead carefully insert the values. 4/5 for cosine U, and cosine V is negative 12/13. Sine U is 3/5. And sine V, it's negative 5/13. So now just have to be very careful in handling all these fractions. So these fractions are both negative. Okay, so first one will be 48/65. And then you have a minus 15/65. That gives you a total of 63 over, I'm sorry, 65, sorry. 63/65. Okay. So like I said yesterday, if you are good with fractions, this should be okay. If you are not good with fractions, you will be good with fractions because you have to. All these fractions addition and fraction addition and multiplication. Okay. Now we'll work on the tangents together. Now I can tell the nightmare is coming for tangents because we have some more ratios to deal with. So for tangent, so we have tangent U plus tangent V all over 1 minus tangent U times tangent V. Okay, so we didn't get the tangent value yet, so let's go ahead and get the tangent value. So we say tangent U is 3/4. And tangent of V is 5/12. It's positive because it is in quadrant 3. Okay. So so we can just go ahead and substitute. All right, so we just go ahead and substitute. And now I will tell you again, most people, they stumble here, not because of the tangent values. Most people stumble here because of these signs. So please don't miss the signs. So tangent U, it's 3/4. Tangent V, it's 5/12. And 1 minus 3/4 times 5/12. So enjoy working with these fractions. So for the numerator, you would have, well, let me do it step by step. So have to have a common denominator. Okay. And then for the denominator, I would have 1 minus 15 over. Oh, hold on. What am I doing? No, that's not a good move. You know why? Originally, I wrote down 15/48. That's not a good move. You know why? Simplify first. Okay. Why would I do extra work when I don't need to? Okay. So that gives me 5/16. A lot easier. Okay, to multiply, to handle the numbers. Yes. Well, you mean you can do 15/48. There's nothing wrong with it, but it's not a good habit. It's never a good habit if you choose to multiply and then simplify. A good habit, it's always simplify first. That makes your life actually a lot easier. So the numerator becomes 14/12. And then the denominator is 9/16. And then let's go ahead and simplify the numerator, which is 7/6. And then there's nothing you can simplify over there. So now, like I told you before, how do you? 9. 16 minus, oh, wait, hold on. 11, yes. Yes. Thank you. So it's just like what I told you before on how to handle complex fraction. So if you have a complex fraction, that means you have the top fraction divide by the bottom fraction. And what you learned back in elementary school is that when you divide by a fraction, you're multiplying by the reciprocal. When you divide by a fraction, you are multiplying by the reciprocal. And that's why, if you are not comfortable with complex fractions, you need to be comfortable with complex fractions. Again, you simplify before you multiply. So you have 56 over 33. Okay. Yes. Oh, zoom out. Okay. All right. So a bunch of numbers. It's not divisible by 3. It's not divisible by 11. So I think that's it. Say again. After you simplify 3 and 12. This is a 1. 1 times 5 is 5. 4 times 4 is 16. Okay, so like I said, you will be good with fractions. And you need to be good with fractions. And this is the part for those who do not show good handwriting. If you don't show good handwriting, you become your own victim. Okay, so please. Okay, I have all these good notations, not because I love to, it's because I need to. And when you go to calculus, you need to have this kind of good organization skills to handle your numbers, because there will be a lot of numbers for you to handle. And if you don't care about what you're writing, then that's a consequence. There's a consequence. Okay. So now I would like to do a couple more problems. Now the bottom questions are just, the last question is just, well, we'll come back to that later on. So let's go ahead and go to the worksheet page. And let's go ahead and take a look for the question 3 through, wait, hold on. Look at question 3 through 6. 3 through 6. You can go ahead and cross out number 7 and number 8. I don't know why they're there. Go ahead, cross out number 7 and number 8. Okay, they shouldn't be there. So we have two triangles. So we have two ratios, two angles. We have angle X and angle Y. They are both being in quadrants 2. So that makes sense because you can see sine being positive and cosine being negative. Okay, so we say, well, for the triangle that involves X, oops, we have opposite over hypotenuse being 5/13. So that's angle X. And you may go ahead and this is sine X. So you would need cosine of X. So cosine of X, it's going to be negative 12/13. Don't forget the negative. Don't forget the sign. For me, I always take care of the sign at the very beginning of the process. Because I know for one fact, which is if I get the ratio first, then I would be too excited and I'll move on and I'll forget about the sign. So knowing that it's in quadrant 2, then I know cosine must be negative. And for the other triangle, we have the angle Y. It says is 3/5 for adjacent over hypotenuse. So that means our sine Y must be 4/5. And it will be positive because it is in quadrants 2. So with these two angles, these two triangles drawn, and the ratios given here, now we can do all the things down below. Okay, so we can say that sine X plus Y is simply sine X cosine Y plus cosine X sine Y. And then just go ahead, use parentheses to put the fractions in and make sure you do that very carefully. Cosine X and then sine Y. Doesn't seem like, oh yeah, that's something to be simplified right here. So there's a 5 right here, there's a 5 right here. That could be canceled. And don't think there's anything else you can simplify here. So you have negative 3/13 minus 48/65. So if you want to combine them together, so you have to multiply the first fraction by 5, which is negative 15/65 minus 48/65. And that should give you a negative 63/65. Okay. So that's the kind of procedure you will carry out. Okay. So take a moment. Okay. Finish the 4, 5, 6 on your own for the next 5 minutes. All right, let me continue to work on this. So cosine of X minus Y, it's cosine X cosine Y plus sine X times sine Y. So we go ahead and draw my parentheses. Cosine X, it's negative 12/13. Cosine Y, it's given, which is negative 3/5. And then sine X is 5/13. Sorry, 13. And then sine Y, it's 4/5. And again, fortunately, I got something to be canceled out. Anything else? So keep going. So I got 36 over 65 plus 4 over 13. So I got 36 over 65 plus 20 over 65. That gives you 56 over 65. Okay, so that's the ratio for number 4, 56 over 65. Okay. And then for number 5, it's cosine x cosine y minus sine x sine y. It's equal to, can list out all the fractions here. Cosine x. Okay, well, it's basically the previous one. Okay, basically like the previous one, except that it is a subtraction rather than an addition. So you've got 16 over 65 as the answer. Okay. And for number 6, well, it's like the very top one, except that it's now, well, hold on, sine y minus x. So sine y cosine x minus cosine y sine x. So sine y, it's what is sine y? Sine y is 4/5. 4/5. Cosine x is negative 12 over 13. Cosine y, it's negative 3/5, and sine x would be 5 over 13. So if you look at it, you can reduce to 5. Well, actually, maybe let's just go ahead and keep the 5. Because I'm gonna do the common denominator anyway, so there's no point of simplifying. So you get negative 48 over 65 plus 15 over 65. So that gives you a total of negative 30 over 65. No, 33. 33 over 65. Okay. So I hope you don't find it too challenging. It's just a bit tedious, and you have to be very diligent with your handwriting. Okay, so do not skip around. Okay. Now, I would tell you that these two questions, both question 1 and question 2, they are like the quiz question. I just look at the quiz, and they are very similar. Okay, so we're like, hey, we give you 2 angles, one in degree, one in degree, the other one is in radian. And can you go ahead and find out either the sum or difference, okay, of these 2 angles, okay? And if you go back to the previous page, okay, for this one, well, let's see how things go here. So, you have a sum of angles, okay? So sine x cosine pi over 6 plus cosine x sine pi over 6. That's the first part. And then you have sine x cosine of pi over 6 minus cosine x sine of pi over 6. It's equal to 1/2. Okay. Now what you will see is that this expression and this expression, they are identical and they're subtracting. Well, there you go. And then what is sine of pi over 6? Sine of pi over 6 is 1/2. So you have 1/2 cosine x plus 1/2 cosine x, because you have negative and negative, you have positive. So that means cosine x is equal to 1/2. We say, hey guys, if cosine x is equal to 1/2, what's the angle? If the domain is from 0 to 2 pi out of 4 quadrants, what angle gives you 1/2 for cosine? And we say that would be pi over 3 and 5 pi over 3. Okay. So that's more like the stuff that we would do on next Monday, the stuff on Monday. So now, let me tell you what you will be responsible for the quiz this coming Friday. Make sure you know the identities. Okay, so there'll be one, just like these two, as I said. Okay. Make sure you can do the stuff from yesterday, actually. So yesterday was this stuff. So you know, the beginning stuff right here. If we give you something like these, could you give me this? So just recognizing that, oh, hey, this is the sum of 2 angles for sine. Then just do this, write down this as the answer. Right, it's nothing to compute, basically. It's just finding out what it looks like. Done. So 2 questions. Yeah, 2 questions. 2 questions like this. 2 questions like what I showed you earlier. These guys. And then the remaining questions will be from the stuff tomorrow. Now tomorrow, we will look at the double angle and half angle. So you will be responsible for the double angle identities, which is here. Okay. Now, double angle identity is actually, now if you say, oh, I forgot about this. Is there a way out? Well, if I ask you that question, that means there is a way out. So what is 2x? 2x is the same thing as x plus x, right? So if you say, hey, I can look at 2x as x plus x. Hey, and I also know the identity for the sum. So that is what? That's sine x cosine x plus sine x cosine x. And that's why you have 2 sine x cosine x. What about the cosine 2x? Well, you can look at this as cosine of x plus x, which is cosine x times cosine x minus sine x sine x. And that's how you have cosine square x minus sine square x. And, well, what about these 2 variants? Okay, how come we have these 2 things? Well, didn't you learn about the Pythagorean identity? That cosine square x is equal to 1 minus sine square of x. So if you can replace this with 1 minus sine square of x, you got this. If you replace sine square of x with 1 minus cosine square of x, then you get this. Yes. Well, I didn't. This one is on Schoology. I didn't print it out, but we'll go into this tomorrow. Okay, I'm just giving you a little heads up. Like this is not something new. You can actually generate this based on our existing knowledge. And same thing right here, tangent 2x. Just think about this as tangent of x plus x, and you can see how you obtain this one. Okay, so we'll do more tomorrow. It's really simple, just putting things together. The thing about the quiz is that this would all be given to you. You do not memorize this. So what you're responsible for is the sum and differences. If you know the sum and differences, you will be able to get this as well. Okay, if you are using your logic to push the writing. Okay, so we'll continue tomorrow, so I can work on these sum and differences. Okay, make sure you can write all those identities here. Make sure you can write all those here.